Hello, welcome once more. Welcome to Cerp TV and welcome to our calculus class. I hope I met you well. So we continue to move on. Now we have a problem on the board that says we should evaluate limits as h is tending towards 0 of the square root of 2 plus h minus the square root of 2 divided by h. Now when we substitute 0 into this problem directly, you discover that we are simply going to get 0 over 0. And like I have explained in my previous videos, 0 over 0 is a typical example of what we call an indeterminate form. So what could we do to avoid the indeterminate form? Now we begin. What I'm going to do, this is what we call a surrogate expression. We are going to multiply numerator and denominator by the conjugate of the surd. So this simply becomes limit as h tends towards 0. Now this is the surrogate expression, 2 plus h. Now minus square root of 2, okay, divided by h. Now we are multiplying numerator and denominator by the conjugate of this. And the conjugate of this simply becomes square root of 2 plus h. Now instead of minus, we are going to have plus square root of 2. Okay, now divided by square root of 2 plus h. Now plus the square root of 2. So that's the sort of thing we were supposed to do. Beautiful. Now all this should have been in a bracket. Good. And this now becomes equal to, we now have limits as h is tending towards 0. Now notice something, we are going to expand these two brackets. These are two brackets that need expansion. Now square root of 2 plus h times square root of 2 plus h is simply going to give me 2 plus h, because we know that normally the square root of anything multiplied by that same thing will simply give us a. So if I multiply root 2 plus h and root 2 plus h, so I'll simply have 2 plus h. Then this multiplied by root 2 will simply give me plus square root of 2 multiplied by square root of 2 plus h. Beautiful. And then we now have this, multiplying this, we have minus root 2 multiplied by square root of 2 plus h. And then root 2 minus root 2 multiplied by root 2 simply gives me minus 2. Now all divided by, you see all that is divided by, we now have h into square root of 2 plus h. Now plus the square root of 2. That is this one multiplying that one. Okay, we now begin to simplify. You discover that this becomes equal to limit as h tends towards 0. Now notice something, this term will cancel this term. So what do I have here? Now also notice that 2 will cancel minus 2. So what remains in the denominator simply becomes h divided by, then I now have h into this term, square root of 2 plus h. Is that okay? Now plus the square root of 2. We close that. Okay, beautiful. Now notice something. H would strike out h. Now if h cancels h, what do we now have? This becomes equal to limit h tends towards 0 of 1 divided by square root of 2 plus h plus square root of 2. We can now set in our limiting value. If we set h being equal to 0, what do we get? So it simply becomes equal to 1 divided by square root of 2 plus 0. Remember that h is 0. Then we now have plus square root of 2. Beautiful. And 2 plus 0 is 0. So please, this division has to cover everything. And this becomes equal to 1 all over square root. 2 plus 0 is 2. So I have 1 over root 2 plus square root of 2. That is this other square root of 2 here. And at the end of the day, square root of 2 plus square root of 2 will simply give me 2 root 2. Okay, so I simply have 1 divided by 2 square root of 2. And that becomes our final answer for that problem. Thank you so much for tuning in to Cerp TV. Please do well to subscribe. And when you subscribe, click on the notification bell. That way you get to know whenever we are dropping a new video. Thank you so much and do have a wonderful time. Bye-bye.